الرحیم. امروز روز بحث 19 اردیبهشت ماه 1401 جلسه 9 درس زمین آمار در خدمت عزیزان هستیم. If I want to have a brief account of what we said for the last 2 or 3 sessions, that has something to do with how to prepare experimental, either directional or omnidirectional variogram as a function of separation distance. And it's quite important to differentiate between regular versus irregular space data. That's the very first important thing to consider. And then if you would like to go for the second step in geostatistical analysis, say variogram modeling, at first you have to decide whether your data are vector-based or raster-based. That's the first item that you need to consider. As soon as you fix the nature of your data, say raster-based data, then you have 2 possibilities. Fix the direction, say I would like to prepare experimental variogram for east-west direction or north-south direction or whatever direction, and then try to prepare a number of scatter plot, extract a single number, either measure of variability or measure of similarity from each scatter plot, and then prepare a table where the first column is separation distance, the second column is the experimental variogram. If you would not like to go for experimental directional variogram, then you would extend your search to delineate pairs whose separation distance is h2, h3, h in any direction, and then prepare gamma as a function of separation distance for any direction. Today, I would like to give a brief account of the case when your data are vector-based, irregularly spaced, and then you would like to prepare experimental directional variogram for vector-based data. I prepared this, I extracted this from GS library, manual, and then converted it to PDF, share it with you through your email, this page. Let me raise the question. The question is, if your data are vector-based, that is, irregularly spaced data, and then you would like to answer this question, whether your data are isotropic or anisotropic. One way to decide whether your data are anisotropic or isotropic has something to do with preparing experimental variogram for a number of directions, overlay them on each other to see if they are the same. If they are the same, then you would say your random function is isotropic. If they are not the same, then your original random function is not isotropic. And I will allocate 2 or 3 sessions touching on anisotropic phenomena, how to treat anisotropy in geostatistics toward the end of the course. Today I would like to talk about the parameters where a program so-called GAM-V in GS library require to prepare experimental directional variogram for irregularly spaced data. And if you have mobile on your system, you can retrieve this page on your mobile in case you can connect it to internet. Perhaps it might help to tell you what is given and what we are looking for. It's because it's quite important to have the general problem stated. Given a single partial realization of a random function that is what we are given. And then we would like to make a decision on nature of anisotropy or isotropy. You are given a single partial realization of a random function, then we would like to make a decision on nature of anisotropy. Of course, it is up to you to make a decision on your Cartesian coordinate system when it comes to these data, because this SI here could be the X for 1D, X and Y for 2D, X, Y, and Z for 3D. And of course, if you are talking about coordinate, then you should consider a Cartesian coordinate system or cylindrical coordinate system or a spherical coordinate system. It is preferred to select your Cartesian coordinate system so that none of your points has negative either X or Y coordinates. It should be in the first quadrant. It is up to you to make that decision. This is your X1 corresponding to X, and this is your X2 corresponding to Y. And if it is 3D, then you have a third direction, and then you have a 4D problem. And then the parameters that you need to consider, you have a bunch of data on these first quadrants. And then you would like to prepare directional variogram, assuming that your data are irregular, vector-based. There is no organization in monitoring the study area. The very first item that you have to consider is the azimuth. The central direction where you would like to prepare directional variogram. Azimuth is the angle created between the direction of interest and north. And that is what you need to incorporate into GS library. The angle where your direction under consideration will make with the north is called azimuth. In GS library, this is denoted by ANG. Here is a program so-called YAMV, customized to do the calculation of experimental directional omnidirectional variogram. And then you have to consider a region around this line and limit your delineation of data pairs allocated to this region. And the region is considered to be like this. All data allocated to this region will be considered for delineation of data pairs. As soon as you limit yourself to these data for preparing directional variogram in this direction, then the situation is going to be the same. You have to delineate the maximum separation distance. You have to limit your discretization of distance into 2/3 of this maximum separation distance. And then you have two possibilities to discretize this distance, either equal interval for which the number of pairs in each interval is going to be different, or you may have variable interval for which the number of pairs in each interval is going to be the same. And then try to use the summation that I introduced in my previous lecture to obtain the experimental variogram. And when it comes to the separation distance, you have 5 possibilities to compute the separation distance for each interval. And then that will give you a table where gamma is a function of separation distance. The number of items that you need to consider here is this is a distance where you have to incorporate it into GS library, and lag tolerance X L T O L. This is X T X L T O L, which is the same as this. And then you have another item, so-called tolerance atoll, which is from here to here. And it is denoted by ATOL. It is equal to 22.5, or it can be given by you. This distance here maybe I'm talking about totally different things. Bandwidth width, excuse me, this is not related to this. This is this distance here has to be totally different thing. This is the bandwidth, and it is denoted by BAND W. And the numerical data given on this diagram concerned with the parameter file written in this manual to tell you where you need to incorporate this data into your program. Bandwidth, which is the same, and then here you have X lag from, you have to perhaps discretize this into a number of intervals in order to go ahead and find the experimental variogram in each interval. And then when it comes to the first distance here from 0 original of coordinate system up to, say, half of this distance, from here to here is called X lag, and then perhaps from here to here, if this is the typical interval for discretization, then half of this distance is called X LTOA, which means that the discretization is twice of this parameter. And then from 0 up to the first half or some portion or percentage of this distance is called X lag, and it is in this diagram it is 4, this is 4, and this is 2. And I'm quite sure that if you look at the page on GS library, the manual, you would explore some other parameters where you have to fix this region, and then as soon as you fix this region, you are ready to go for computation of experimental variogram. Either your data is regularly based, or your data is irregularly based, or you would like to go for directional or only directional variogram. The end result is going to be a table. And this table is H, comma H. The end result is going to be this table. In my previous lecture, I brought an example of a PhD student where after 6 months he referred to me saying, Mr. Abedini, I am getting negative variance. What should I do? And I asked him whether he did consider fitting a theoretical variogram to his experimental variogram or not, and he all of a sudden said, no, I did work with this table instead of working with theoretical variogram. Now, the question is, if you are given this table, this is experimental variogram. Experimental variogram. Either directional or omnidirectional. At first you have to consider these data to be corrupted by noise. And you know why these data are corrupted by noise. Because you have 5 possibilities for this. And this column is highly connected to your decision on nature of discretization, directional, omnidirectional variogram, and so on, because of the nature of these data on these 2 columns, where they are highly corrupted by noise. If you want to go for estimation using this table, sooner or later you are going to get negative variance. And negative variance in geostatistics is a total disaster. Raw variance cannot be negative. At most, variance is 0. Where the variance is 0? When your data are the same. When every data has the same numerical value, then the variance of these data is 0. If there are variability in your data, then variance is going to increase. The more your data are variable, the higher the variance is going to be. Therefore, you have to consider fitting a closed form function to these columns. Here, I would like to introduce three types of variogram. The very first type of variogram is theoretical variogram. Then regional variogram. Then experimental variogram. If you remember, at some stage where we switch from virtual session to physical session, I brought two examples for you. Remember those two examples? In those two examples, we try to define a closed form function for your random function. The first example has something to do with having a random variable wi, and this random variable could take either +1 or -1, and then we connect a random function to this random variable through y at n equal to the summation I from 0 to n wi. In that case, you realize that if you are given the random function, then we can easily compute theoretical value. The very first example y sub n That is the definition for the first example. We showed that this random function is not stationary. Why? We argue that this expected value of y is independent of n, that's okay. But when it comes to variance of y, we realize that variance of y depends upon n, which means that variance is variable. And then we realize that this random function is intrinsic, not stationary. And then we realize that the variogram corresponding to this random function gamma as a function of k is equal to 1/2 times k. This k is considered to be separation lag. K is equal to n sub I minus n sub. This is theoretical value. When it comes to our second example, the closed form function for our theoretical random function was x equal to sine of 2 pi x plus w. If you denote this by lowercase letter, then this has to be in lowercase letter as well. If you denote this by uppercase letter, then this W has to be written in capital letters. This is our second example. And we realize that for this second example, you could easily prove that your random function is stationary. And your covariance function are as a function of separation distance h if you remember is, can you check Mrs. Orajab to see if this is the same? R sub h is equal to 1 over 2 cosine of separation distance. Two pi times h. Again, this h here is equal to xi minus xj. And your variogram as a function of h is equal to 1 over 2 minus 1 over 2 cosine of 2 pi h. Which is, if you remember, we argued that cosine of 2 pi h can be written as either 2 times cosine to the power of 2 pi h minus 1 or 1 minus 2 times sine of pi h. If you use this relationship, sine of pi h is equal to 1 over 2 minus 1 over 2 cosine of 2 pi h, which means that you can replace this with sine of pi h. The reason why I bring these two examples into your attention today is to argue that in real life we do not have access to these closed form functions for a variety of reasons. If you want to defend this argument regarding why you could not delineate your closed form function for random function, that has something to do with nature of randomness. Here we argue that this W is uniformly distributed between 0 and 2 pi. How could it be possible to delineate the nature of randomness when you are given a single partial realization of your random function? You have only one number at each point. Here you could generate infinite number of realizations for your random function. All you need to do is to press a button on your pocket calculator, convert it to a uniform number between 0 and 2 pi, plug it here, and that will give you a realization. Repeat this process for another uniformly random number between 0 and 1, convert it to 0 to 2 pi, plug it here, you are going to get a new realization for your random function. But in real life, you have only one single realization. Therefore, in real life, we do not have access to theoretical covariance function or variogram function. Time is limited, money is limited, labor is limited. If you look at these three types of variogram here, and you would like to define it in your own term, theoretical variogram could be delineated if you do have access to your random function, closed form function for your random function. But since you do not have access to your random function in closed form, then you do not have access to theoretical variogram. What do we mean by regional variogram? If you have a chance to monitor every point in a space, which means time is not limited, money is not limited, labor is not limited, then you could delineate regional variogram having data at each point in space. In a sense, this is another way of talking about theoretical variogram. When you look at this 1D random function, you could decide where you would like to have a numerical value for y, assuming that your inherent randomness is freeze. Then all you need to do is to plug a numerical value for x, compute the sign of this argument here, and that will give you a numerical value for your random function. Regional variogram could be delineated if you have numerical value for your random function at every point in a space, which means that you could have access to closed form function for random function to be able to have access to your numerical value of random function. This is not accessible, regional value. If time is not limited, if money is not limited, if labor is not limited, in that case you could monitor every point in a space physically. If you do have access to your random numerical value of your random function at every point in a space, then you could go ahead and obtain the regional value.
پس ریجنال واریبل در واقع یک واریبل اکسپریمنتالی که داده‌های اون پرفکت و بدون نقص باشه.
But in real life, we do not have that scenario where time is not limited, space is not limited, money is not limited, and labor is not limited. In fact, this regional variogram is a bridge connecting experimental variogram to theoretical variogram. It is not accessible. And this one is accessible only when your random function is given in closed form. In real life, you could delineate experimental variogram, where we talked about this in our two previous lectures. And that is the table associated with experimental variogram. It's going to be a simple question in curve fitting to connect theoretical variogram to experimental variogram. If you go back to your course so-called numerical analysis, Bachelor of Science. In that course, you are familiar, if you are given a table on X versus Y. You are familiar how to prepare a closed form function for Y as a function of X. And as soon as you delineate a closed form function connecting X to Y, then if you are given X, you can plug it into your relationship to find Y. Just very similar to what we are planning to do here. Here's a book written by Bart. I prepared 2 copies of this book from your library, you people, Geological Science Department. It was written in 1974. And the title of this book is Nonlinear Parameter Estimation. In fact, the reason that I am familiar with this book has something to do with a course which I took in my PhD, optimization. In that course, I did not took it for credit, but like Mr. Zairi, I took it for audit, just audit that course. And the person who taught that course was from the Department of Mathematics, not from our own engineering school. In that course, I became familiar with this guy, and I do have the electronic copy of this book. I can share it with you. And the title of this book is Nonlinear Parameter Estimation. If you start to read this book, in your first chapter, this author argued that if you want to find a closed form function for connecting Y to X, you have 2 degrees of freedom. Please pay attention to these 2 degrees of freedom. If you want to connect Y to X, you have 2 degrees of freedom. How to define a mathematical function to connect Y to X. This is not unique. The second degree of freedom that you have concerned with measure of goodness. If that is your x-axis, that is your y-axis, and you map your data for x versus y on your first quadrant, you are going to have a series of data. These are your data points. Please pay attention. When I'm talking about y versus x, that means I'm talking about gamma versus h. They are the same. But you are more familiar with y versus x as opposed to gamma versus h. 2 degrees of freedom. How could it be possible to choose a mathematical formula to connect y to x? That is the first degree of freedom. There's a program so-called Easy Fit. No, not Easy Fit. Table check. easily search for this program in your Google search. In table care, you have 3,000 mathematical models. If you introduce your data to table care, it will search among these 3,000 mathematical models to see which one is going to be more appropriate for your data. And then the second degree of freedom that you have has something to do with measure of goodness. If you remember, one of my PhD students who defended his thesis very recently, Mr. Shahriyar. At first I raised a question for another PhD student whose name is Mr. Danishwood, is the son of Mr. Danishwood Experimental Laboratory in our city. I raised a question for him that I have no answer for this question. He defended his thesis but did not answer that question. Mr. Shahriyar also defended his thesis but did not answer that question. And I will raise it for you today to see if you can find the answer for that question. And that question has something to do with those 2 degrees of freedom as well as independent data versus free from error data. I will talk about that question here because at first when I decided to introduce the student, the examining committee and the title of his thesis, I raised that question and it is in my apparat, the defense session, and I will raise it for you today to see if you have some interest in that question. And I even raised this question for Professor Gilbert Strang, Department of Mathematics, MIT University. And he decided to say, no, I have no answer for this question. And it's quite simple, that question, by the way, not a complicated question. But let me tell you what do I mean by degree of freedom. The first degree of freedom that you have has something to do with mathematical model. Which mathematical model should be connected to this data? The second degree of freedom that you have has something to do with measure of goodness. What do I mean by measure of goodness? If your mathematical model is a linear relationship, then how could it be possible to delineate this linear relationship? You have a variety of choice to make this decision. Please pay attention. I fix my mathematical model, linear, and I would like to go ahead and find a relationship for y versus x. As simple as this. I would like to obtain A and B given a table for y versus x. I fix the mathematical model and I would like to address what do I mean by measure of goodness. If you want to decide on measure of goodness, you have to make a decision on these 3 scenarios. The first scenario is to say x is not corrupted by noise, but only y is corrupted by noise. In that case, what you need to do is to obtain these distances, square them, If you ask me what are these distances, I would say from here to here is y(r). That is what you observe. And from here to here is what you compute. And if you subtract this from this, you are going to get error. And if your y is corrupted by noise, what you need to do is to obtain A and B is to minimize sum of square error. Your objective function is going to be A, f as a function of A and B, and this is summation I from 1 to n is the number of data, epsilon I to the power of 2. That is one possibility. If your x is not corrupted by noise, and your y is corrupted by noise, all you need to do is to square these little distances, sum them up, and then try to minimize f. By the way, I was wondering whether you are familiar with this or not. These are from Bachelor of Science, not even Master of Science. Yes or no? Are you familiar? Yes? Definitely? Good.
یه چیزی شما رزیجوال میشه در واقع تفاوت
These are residual, yes. These are residual. Now, what if X is corrupted by noise, but Y is not corrupted by noise? It's quite interesting for you. I took a course in groundwater hydrology with a professor in University of Wales. Out of my surprise, and out of your surprise, he did not know that if you want to find A and B, you have to make a decision whether your X or Y or both are corrupted by noise. And even he did not know that if Y is corrupted by noise but X is not corrupted by noise, is the same as the case when Y is not corrupted by noise but X is corrupted. He thought for both cases you are going to get the same A and B. Definitely wrong. If X is corrupted by noise but Y is not corrupted by noise, what you need to do is to find these distances square them, and then try to minimize the obtained function. Which means you have to write it this way. And then define an objective function g as a function of c and d to be equal to summation I from 1 to n, and in order not to confuse it with epsilon, let me call this eta. These are eta. Again, from here to here is xi. From here to here is x hat I, and x hat I minus xi is going to be eta I. It's quite interesting for you to acknowledge the fact that if you convert this to this, you are going to get x equal to, what you need to do is to divide both sides by A, I just bring this on the other side, divide both sides by A. You are going to get the same C equal to A1 over A and B equal to minus B over A only if, please pay attention, only if your data points are located on the line itself. فارسی شما اگر چنانچه برید این مسئله رو حل کنید یا برید این مسئله رو حل بکنید رابطه بین C مساوی 1 روی A و D مساوی منهای B روی A درسته به شرطی که تمام نقاط روی خط باشد. اگر چنانچه نقاط روی خط نباشند C با 1 روی A برابر نیست و D روی منهای B روی A برابر نیست. The third goodness of fit criteria is to assume that both X and Y are corrupted by noise, which is the case here. Both your X and gamma is are corrupted by noise. But please answer this question. If you manage to delineate a single paper, please pay attention. If you manage to delineate a single paper in literature to assume that both H and gamma are corrupted by noise. In conventional literature that you and me have access to, assume that H is not corrupted by noise and only gamma is corrupted by noise. If both X and Y are corrupted by noise, then neither epsilon I nor eta I has to be considered. Neither epsilon I nor eta I. But these distances.
epsilon صفر باشه بی هم صفر میشه درسته؟
Pardon me?
اگر اپسایلون صفر باشه بی هم صفر میشه اینجا اگر اتا صفر بشه در واقع دی صفر میشه درسته؟
What do you mean by epsilon to be zero? Epsilon for every point?
آره همین نقاط هستن
Which means that the data are located on a line?
آره دیگه بی صفر میشه درسته؟
No. In that case C is equal to 1 over A, D is equal to minus B over A. If your data are located on a line.
خط دیگه از مبدا میاد خواسته.
No. In that case, you have to have a point 0 and 0 in your data set in order to be passing through origin. It may happen that in your data there is no point 0 and 0. I wish I offered a course on linear and nonlinear regression analysis for a semester. Not for a single session, but for a semester to talk about these things. Because it is quite important. Every student in every discipline, one way or another, needs to know this. The third possibility is to consider the case where both X and Y are corrupted by noise. In that case, I will use this color to show that you need to have a perpendicular line and try to minimize the sum of the square of this distance. This is eta, this is epsilon, let me call this key psi. If both X and Y are corrupted by noise, then this is FGH as a function of E and F. has to be equal to summation I from 1 to n, kisa I to the power of 2. In this case, your x is not corrupted by noise, but y is corrupted by noise. In this case, x is corrupted by noise, but y is not corrupted by noise. In this case, your model is either Ex plus F. Even, please pay attention, I limit myself to linear relationship, not 3,000 mathematical model. And then you have this possibility. The fourth possibility, can you imagine what would be the fourth possibility? For goodness of fit criteria.
ايش برای کل مدل هستش؟
Pardon me?
خود F و G ها متوجه شدن.
This is a function. This is operator. This is a function for which it has two arguments. H is a function. It has two arguments, E and F. It's a function. Are you familiar with f's of x? Now, x is not your independent variable. Here, your independent variable is A and B, C and D, E and F. The fourth goodness of fit criteria is considered to be Chebyshev criteria, where you will try to delineate maximum departure, and again you have three possibilities for that maximum departure. Maximum departure for epsilon I, or maximum departure for eta I, or maximum departure for psi I. I try to minimize this maximum departure. In literature, it is called minimax problem. Chebyshev. You will delineate maximum epsilon I, and you will find A and B to minimize this maximum epsilon I. You will delineate maximum eta I, and you will minimize maximum eta I. You will delineate maximum psi I, and then you will minimize maximum psi I to obtain either A and B, C and D, E and F, and so on. This is called Chebyshev criteria.
روش‌هایی هست اسم روش کمترین مراقبات ریگرسیون شده.
OLS, ordinary least square. Least square. In least stand for minimizing. F square implies that some of these epsilon are negative and some of them are positive. Please pay attention. If you define your epsilon to be y hat I minus yi, then according to this definition, for these data which are below the line, epsilon is positive. For data above the line, epsilon is negative. Therefore, you have to square them in order to get rid of the negative sign. At some stage, toward the end of your life, maybe 120 years, you might become familiar with philosophy of science, falsafa, or history of science, tarikh. In those two courses, You might be interested to dig further into history of this square. Can you imagine at early stage what happened to this square? At early stage, instead of raising it to the power of 2, they will try to find A and B by summing absolute value of epsilon I. Trying to get rid of the negative sign by taking absolute value. But sooner or later they decided, oh, absolute is not a good sign for minimization. How could it be possible to obtain A and B if the objective function is to minimize the summation of absolute epsilon I? Can you imagine what happened? And then gradually they change absolute value to epsilon to the power of 2. As soon as you replace this epsilon I with this, f sub A is going to be summation I from 1 to n, and then you have to put y hat I minus yi to the power of 2. It really doesn't matter whether you put y sub y minus y hat I or vice versa, because as soon as you raise it to the power of 2, the minus sign will cancel out. And then you could replace this y hat of I with a x of I plus b minus y sub I, because that is what you will compute. And then you have an objective function where you have no degree of freedom on x, y, and y, which is what you observe, and all you need to do is to play with numerical values of a and b to minimize f. Partial value of f with respect to a has to be 0, and partial derivative of f with respect to b has to be 0. And that will give you, look at and see how I'm going to take partial derivative of f with respect to a. These two will come in front of the parentheses, and then I have to take partial derivative of this with respect to a, which is going to be x sub I. And then I have to multiply it by the same parentheses with 1 power less. That is how to take partial derivative of f with respect to a. And then when it comes to this one, again you have to bring this to here, and then partial derivative of this part with respect to b is going to be 1, and then times a xi plus b minus y. Two equations with two unknowns. You can simplify, these two cannot be 0, it will cancel out, and then you could write this as summation I from 1 to n xi to the power of 2 times a plus summation xi times b equal to summation xi y. And when it comes to this one, xi times a plus n times b equal to, and of course I has to go from 1 to n for every summation. Two equations with two answers. Today I would like to prove this two relationship using matrix notation. And then gradually move to nonlinear regression. Can you tell me why I should go to nonlinear regression instead of linear regression? You are thinking about this one, yes? The mathematical relationship is this, then you have to use the same procedure to write down two equations with two unknowns for C and D and solve the linear system of simultaneous equation. If you want to play with this, soon or late you will be confronted with PCA, principal component analysis. When your independent variable as well as dependent variable is corrupted by noise, then sooner or later you will run into principal component analysis, and this is a very important topic, very attractive topic. Mr. Shahriyar worked with supervised principal component analysis. But if you want to avoid working with principal component analysis, what you need to do is to obtain these psi in terms of A and B, and then try to follow the same procedure that you have for either F or G and obtain E and F when X and Y is corrupted by noise. Now, I would like to obtain these two relationships using matrix notation. How? If that is your model, then you can write this as observed value of Y can be written as that is how to relate computed value with observed value. This part is Y hats at I, and this is epsilon I. If I want to be more specific on I from A to N, then I have to replace I with 1, I with 2, I with 3, and so on, and see what will happen. Y sub 1 is equal to A x1 plus B plus epsilon 1. And then when it comes to y2, y2 is equal to ax2 plus b plus epsilon 2. Keep going. Yn is equal to axn plus b plus epsilon n. Could it be possible to write this system in matrix form? Why not? And I have to add this is, let me write it in different color. This is going to be a matrix of n by 1, n rows, 1 column. This is going to be n by 2, n rows and 2 columns. And this is going to be 2 by 1, 2 rows and 1 column. And that's going to be n by 1. And of course, every component should be n by 1. See, n by 2, 2 by 1, will become n by 1. Could it be possible to write this in matrix 4? Yes. It could be written as epsilon as a vector is equal to matrix A n by 2 times unknown x. What should I write here? This. What should I write here? This vector can be denoted by S, for which we are looking for this S. And that is plus equal to vector 1. That is how to represent this system. Vector epsilon plus A times S equal to 1. Therefore, epsilon will become y minus AS. Now, from statics, or whatever course you have at your Bachelor of Science, you know that the dot product of these two vectors, epsilon dot epsilon, will give you the sum of the square of epsilon. Let me come here. Epsilon dot epsilon, dot product of two vectors, is equal to epsilon transpose epsilon. Would it be possible to check whether this will give you a number? Why not? This epsilon is n by 1, n row 1 column. This is 1 by n. And then if you multiply 1 by n by n by 1, you are going to get 1 by 1, numerical number. What is the new value of epsilon transpose? This is epsilon, and then you have to put y minus A S transpose times y minus A S. And then you are going to have y transpose, and when it comes to A times S, it will become S transpose A. And you have to multiply this by that. Minus S transpose A transpose times y then when it comes to this one, it will become plus S transpose A transpose A S. These two terms are the same. Why? These two terms are the same. The reason why these two terms are the same is this. Remember that if you have a number like 2, 2 is the same as 2 transpose. Okay? Here you have a number. If you take transpose of this, you can find this. Because transpose of this becomes transpose A transpose Y. Therefore, these two are the same. You can either write 2 times this or 2 times this. Therefore, epsilon to the power of 2 which is epsilon transpose times epsilon. And of course, I use Einstein notation to represent this. Is equal to S transpose A transpose A S minus two times S transpose A, or better to say Y transpose A S plus y transpose y. And that's going to be your objective function, f as a function of s. This s is basically A and B. This vector, if you remember, I call this vector to be A and B. And then I introduce a book, so-called bar. In your first appendix of this book, you will become familiar with matrix algebra. How to take partial derivative of this f with respect to vector s. If you want to check whether I'm doing something right or wrong, after obtaining vector s, I should collapse that relationship to what I have here. Could it be possible to have a trace of s here? Why not? I will show you that this matrix here is A transpose A. This matrix here. What is A? This is A. And this is S. And when it comes to this one, it will be by the way, this matrix here is n by n. Because A transpose is, first this n is, as you can see here, n by 2. And this A transpose is 2 by n. Excuse me, this will be 2 by 2. If you multiply this by this, you are going to get a 2 by 2 matrix. And then if you multiply this 2 by 2 matrix by 2 by 1, you are going to get 2 by 1. And then here, I have to have a 2 by 1 matrix. Let me see. If I put A transpose Y, what will happen? A transpose is what? 2 by n. And this Y is 2 by 1. Excuse me, n by 1. And then if you multiply this, you are going to get 2 by 1. Now, how would it be possible to obtain this relationship here? Partial derivative of f with respect to s. Partial derivative of this quadratic form is A transpose A S times 2. How could it be possible to connect this to this? First appendix of this chapter, this book, minus the partial derivative of this with respect to s is going to be 2 times A transpose Y. And you have to put this equal to 0. Divide both sides by 2, you will have A transpose A times S equal to A transpose Y, which is the same as what we have out there. Vector S, which is A and B, is equal to
A transpose ساده میشه دیگه استاد؟
no. You cannot
چرا؟
multiply this by this. If you want to find S, what you need to do is to multiply both sides by inverse of A transpose A to the power of -1 times A transpose times Y. Let me see if I replace these with their counterpart to see if I can find that one. What would be the value of A transpose? A transpose is this 2 by, I have to have x1, x2, up to xn, and then 1, 1, up to 1. This is A transpose. Okay? And then I have A. x1, x2, xn. This is A transpose times A. And then you have to multiply this by S. And you have to make it equal to A transpose x1, x2, xn, 1, 1, 1 by y1, y2, yn. Let me see if it is okay. 2 by n, n by 1. Okay?
Yes.
You have to multiply this. Please pay attention. You have to multiply this row by this column to obtain the first entry of a 2 by 2 matrix. If you multiply this by this, you are going to get summation of x to the power of 2. If you multiply this by this, you are going to get summation of x bar. If you multiply this by this, you are going to get summation of x bar. If you multiply this by this, n. Now, when it comes to the first row, you have to multiply this by this. And then when it comes to this row times this, you are going to get this one is the same as this one that you obtain from here. من خواستم امروز یک کمی لذت درس خوندن رو برم زیر
جبر خطی هم باید
پس ببخشید من اینجا متوجه نشدم چجوری پا شده پا شده اسو گرفتیم.
گفتم یه تابع هدف دارم که دیگری آف فریدمم، اون چیزایی که میتونم باش بازی کنم که نهایتاً F کمینه بشه، F باید کمینه بشه دیگه. باید بیام مشتق F نسبت به S بگیرم. خود F یک سکیل فانکشنه ولی آرگومنتش وکتوره. مشتق F رو باید نسبت به S بگیرم. خب توضیح دادم، گفتم یه رفرنس اینجا داخل این مجموعه که دارید، منم الکترونیکیش دارم مال بارت هست، اپندیکس 1 این میاد میگه مثلا اگر یک وکتور فانکشن داشتید و خواستید نسبت به یک وکتور مشتق بگیرید نتیجهش چی میشه. اگر یه اسکیلر فانکشن داشتید نسبت به یک وکتور خواستید مشتق بگیرید چی میشه. البته ما تو قسمت استیمیشن خیلی از این اپندیکس استفاده میکنیم، خیلی کرات استفاده میکنیم. البته نیست همینجور من یه سوال کنجکاوانه است خانم بیدا رجب زاده پرسم، این درس راحت تره یا ریاضیات عالی مهندسی؟ این بهتره. خب یه خبر خوشحالی برای شما هست، پس اون رو پشت سر گذاشته ایشی
خیلی حجم زیاد بود، خیلی.
حالا به نظر میاد شاید نمیدونم حالا این تکیه که اینجا مشتقی میگرفتم برای ایشون سوال پیش اومد که چرا مشتقی میشه. یه داستان فوق‌العاده‌ای پشتشه که من توصیه میکنم.
خب اگه اونو بخونید پس متوجه میشید.
بله متوجه میشید. فقط در مورد این من میتونستم هم اینجوری بنویسمش هم میتونستم اینجوری بنویسمش. S ترانسپوز A ترانسپوز Y، هر دوتاش درسته. منتها مشتقی دارم میگیرم، به جایی که اینو بذارم اینو گذاشتم، یه ضریب اینو گذاشتم، A ترانسپوز Y گذاشتم و بعد طرفین به یه دو تقسیم کردم، این به دست آمده، استدلال کردم. گفتم اینا دو تا یه مطلب هستن، منتها از طریق ماتریسی و اون یکی از طریق جبری.
ممنون دکتر.
این مبحثی رو من توی حالا مهندس امیر احمدی مقدار ممکنه با این ملموس باشه ولی اینو تو ترم قبل فقط کاور کردم، ترم قبل اینو کاور نکردم. مفصل تو جبر خطی پیشرفته ما در رابطه با آیگن ولی پرابلم صحبت میکنیم. اینو میگم برای بعضی از دوستان که مقدار دنبال کار موضوع هستن. یه مبحثی توی جبر خطی هست، سینگولار ولیو دیکامپوزیشن. توی آپارات یک از جلسات کامل به سینگولار ولیو دیکامپوزیشن اختصاص داده شده و در مقایسه با آیگن ولیو پرابلم محاسن زیادی داره. این ماتریس A شما میدونید آیگن ولیو پرابلم فقط مخصوص ماتریس مربعیه، فقط ماتریس مربعی در ما چون میتونیم سخن از مقادیر مشخصه بزنیم. آقای دکتر سیدیان سه تا وجوبه داره، میگه اعداد جادویی آیگن ولیوز، بردارهای جادویی آیگن وکتورز، توابع جادویی آیگن فانکشنز. اسم اینا رو گذاشته اعداد جادویی، بردار جادویی، واقعا هم جادو میکنن، جادوگری میکنن. این PCA که اینجا گفتم یه سر قضیهش با آیگن ولیو پرابلم برمیگرده. من توی این روزات باقی مونده سوالی که هم برای دکتر دانشپور هم برای دکتر شهریار تولید کردم و کمان کنم فقط وقت ندارم، یک وقت پیدا کنم خودم برم دنبال پاسخش خدمتتون معرفی میکنم. اینها رو یک زمینه آماده کردم، یه مقداری میخواستم به مرگ بزنم که به تب راضی بشید. منظورم از به مرگ بزنم به تب راضی بشید یعنی هم اونجا رو شروع کنم ریاضی رو بگم که یه مقدار بهتر تعقیب میکنید، هم اینجا رو بدم که تعقیب بشید برید به این کتابه مراجعه کنید و بعد روز آینده که میشه شنبه هفته آینده باید برم برای این جدولی که خدمتتون دادم شروع کنم صحبت کنم. بگم حال چجوری به این من یه تابه فکر کنم. متاسفانه این به اصطلاح داکیومنتی که خدمتتون دادیم، یه بار دیگه این داکیومنت رو نگاه کنید، برایش پنجشنبه حتما این داکیومنت رو ببینید. این داکیومنتی که خدمتتون دادم عنوانش هستش variogram.pdf که آمدن تو صفحات مختلفش variogram رو مختلف رو دادن. مثلا برای همون صفحه اولش که گوسیان variogram هست، تئوریتیکال گوسیان variogram هستش یک ضریبی به اسم سیگما 2 در یک منهای اکسپوننت منهای h2 به l2. این اصطلاحاً به این میگن تئوریتیکال گوسیان variogram. یادتون هست گفتیم سه نوع داریم. این تئوریتیکال گوسیان variogram. ما یه صلیب داریم، میخوام به این فیدش کنم، میشه یه خطی کنیم؟ نه، این غیر خطیه. حالا خانم مهندس زاری میگه آقای خب بدینیم این چرا غیر خطیه؟ از چه دیدگاه غیر خطیه؟ استاتیستیکال یا نگرش سیستمی؟ چی بود نگرش سیستمی؟ گامای H از منظر نگرش سیستمی برای رشن‌زاده باید دیگه بدونه حتما.
الان از لحاظ آماری فکر کنم غیر خطی باید باشه.
فرق نمی‌کنه این عملگر گاما که روی چه اثر میکنه. اگر چنانچه شما بتوانید اینو بنویسید آلفا یو به اضافه بتای بی، اگر این عملگر گاما خطی باشه باید بتوانی این رو بنویسی آلفا گامای یو به اضافه بتا گامای چی؟ بی. اگه بتونیم عملگر گاما خطیه. این منظر نگرش سیستمیه برای خطی بودن یک عبارت. از منظر آماری این رابطه غیر خطیه چون گرافیکال رپرزنتیشن گاما از فانکشن آف H همونطور که میبینید چیه؟ غیر خطیه، خطی نیست. یه خطیش نمیتونید بذارید ادامهش از دو طرف بدید، غیر خطی. این رابطه هم از منظر نگرش سیستمی هم از منظر نگرش آماری غیر خطیه. خب اگه غیر خطی بود، اگه ما خواستیم اینو به این فیت بکنیم، این داده ها رو به این فیت بکنیم، دیگه این چیزی مثل این نمیتونیم عمل بکنیم. نمیتونیم بگیم که شروع میکنیم از این مشتق میگیریم نسبت. میدونیم پارامتر A و B ما چی هستن اینجا. به یه رنگ دیگری دورش خط بکشم بگم که پارامتر A و B اون چیه. این پارامتر A مون هست، این هم پارامتر B مون هست. A و B. اجازه بدید این چند دقیقه من به این مطلب اختصاص بدم و همگی رو خدا بسپارم. یه سوال فاقد پاسخ. یه مدلی داریم y مساوی سمیشن ai xi به اضافه a0. آیا مزید داریم؟ حتی از غیر خطیش هم نکردم. یه ماتریسی هم داریم که آمدیم عملاً بگیم x1 x2 xn و بعد هم y. آمدیم حالا برای که این هم با اینی که بعد میذارم تفاوت بکنه، این میذارم p، یعنی من پی تو متغیر مستقل دارم و این سطر هم داده دارم. رفتم یه پدیده‌ای دارم که اون پدیده به انت متغیر مستقل وابسته است. رابطه بین ایندیپندنت واریبل و دیپندنت واریبل هم خطیه. این داده ها هم جمع کردم. میخوام برم این ضرایب یک تا A0 تا AP رو برای 4 تا گزینه به دست بیارم. ضرایب A0 تا AP رو برای 4 تا گزینه به دست بیارم. این 4 تا گزینه چجوری تولید میشه که بعد ببینیم خودشون چیا میشن. دو تا کانسپت رو باید با هم ترکیب بکنم که 4 تا گزینه تولید بشه و شما الان دیگه باید متخصص شده باشید تو ترکیب کردن این کانسپت ها برای تولید گزینه. اولین این هست که این ضرب x آی ها x1 x2 x3 x آیا مستقل از همن یا با هم همبستگی؟ پس بنابراین dependent versus independent x آیا x1 x2 x3 تا xp مستقل از همن یا با هم همبستگی دارن؟ اگر مستقل از هم باشن شما برید واریانس کوواریانس ماتریکس این ماتریس n در پی رو به دست بیارید باید دیاگونال بشه اگه مستقل از هم باشن. ولی اگر چنانچه وابسته به هم باشن این واریانس کوواریانس ماتریکس این ماتریس n در پی n سر پی ستون آف دیاگونال الیمنت ها که کوواریانس هستن عدد میشه. آف دیاگونال ها میشن کوواریانس، اونایی که رو قطر هستن میشن واریانس. این اولین مطلب. کانسپت دوم خوشبختانه مانی ایجاد کردم این است که آیا این اکس آی ها کراپتد باینومس هستن یا فری فرام ارور؟ همیشه باید کراپتد باینومس فری فرام ارور versus corrupted binomials x حالا 4 تا گزینه که تولید میشه اینها هستن. گزینه 1 خوشبختانه سوال آقای سیراتی هم هایلایت میشه با این گزینه 1 که مطرح میکنم. گزینه 1 داده های x1 تا xp مستقل از همن و فاقد خطا. xi are independent and free from error. آقای مهندس ایلیاتی این گزینه همون OLS. این گزینه که x آیا مستقل از هم باشن و به خطا هم معرض نباشن OLS. دو x آی are independent and corrupted by noise. یادتون باشه که تو هر 4 تا گزینه دنبال ضرایب یک A0 تا AP هستی. چون شما نزدیک دیپارتمنت آمارم هستید اسم برید پیشیشون یه همچه مسئله داریم چیکار کنیم؟ 3 X and I are correlated and free from it. متعالی ترین گزینه X and I are correlated and corrupted by noise. یا تازه شروع هستا بعداً سوال دیگری هم مطرح میشه. بذارید بدونید سوال دیگر رو. فعلا رابطه بین y و x خطیه. اگه غیر خطی بود چی؟ اگه ایمپلیسیت بود چی؟ اگر چنانچه به جایی که جبری باشه ودی بود چی؟ اگه پیدی بود چی؟ خدا رحمون بکن. خیلی ممنون دستتون فرق نکنه. حالا سایده تو راه که داری میگه هم تو راه میگه اصلا